2.5 Balanced equations and related calculations. Equations represent what happens when chemical reactions take place. They are based on experimental evidence. The starting materials are reactants. After these have reacted, you end up with products. Word equations only give us the names of the reactants and products. For example, hydrogen plus oxygen equals water. Once the idea of atoms has been established, chemists realize that atoms react together in simple whole number ratios. For example, 2 hydrogen molecules react with 1 oxygen molecule to give 2 water molecules. So 2 hydrogen molecules plus 1 oxygen molecule equals 2 water molecules. The ratio in which the reactants react and the products are produced in simple whole numbers is called the stoichiometry of the reaction. You can build up a stoichiometric relationship from experimental data by working out the numbers of moles that react together. This leads us to a balanced symbol equation. Balanced symbol equations use the formulae of reactants and products. There are the same number of atoms of each element on both sides of the arrow. This is because atoms are never created or destroyed in chemical reactions. Balanced equations tell us about the amounts of substances that react together and that are produced. State symbols can also be added. These are letters, in brackets, which can be added to the formulae in equations to say what state the reactants and products are in. S means solid, L means liquid, G means gas, and AQ means aqueous solution, that is, dissolved in water. When aluminium burns in oxygen, it forms solid aluminium oxide. You can build up a balanced equation from this and the formulae of the reactants and products, Al, O2, and Al2O3. First, write the word equation. Aluminium plus oxygen equals, we can do that with an arrow, aluminium oxide. Secondly, write in the correct formulae. Al plus O2 equals La2O3. Now, this is actually not a balanced equation because there is 1 aluminium atom on the reactant side, left-hand side, but 2 on the product side, right-hand side. There are 2 oxygen atoms on the reactant side, but 3 on the product side. Thirdly, to get 2 aluminium atoms on the left-hand side, put a 2 in front of the Al. So we have 2Al plus O2 equals Al2O3. Now the aluminium is correct, but not the oxygen. So, fourthly, if you multiply the oxygen on the left-hand side by 3 and the aluminium oxide by 2, you have 6O on each side. 2Al plus 3O2 equals 2Al O3. Now, you return to the aluminium. You need 4Al on the left-hand side. So 4Al plus 3O2 equals 2Al2O3. The equation is balanced because there are the same number of atoms of each element on both sides of the equation. The numbers in front of the formulae, 4, 3 and 2, are called coefficients. And finally, you can add state symbols. The equation tells you the numbers of moles of each of the substances that are involved. From this, you can work out the masses that will react together using Al equals 27, O equals 16. So 4Al S plus 3O2 G equals 2Al2O3 S. 4 moles plus 3 moles equals 2 moles, 108 grams, 96 grams equals 204 grams. The total mass is the same on both sides of the equation. This is another good way of checking whether the equation is balanced. In some reactions, you can simplify the equation by considering the ions present. Sometimes there are ions that do not take part in the overall equation. For example, when any acid reacts with an alkali in solution, you end up with a salt, also in solution, and water. Look at the reaction between hydrochloric acid and sodium hydroxide. So you have HCl plus NaOH equals NaCl plus H2O. The ions present are HCl, therefore you have the ions H plus and Cl minus, NaOH, therefore you have Na plus and OH minus, and NaCl, therefore you also get the ions Na plus and Cl minus. If you write the equation using these ions and then strike out the ions that appear on each side, we have H plus OH minus equals H2O. Overall, the equation is H plus OH minus equals H2O. Much simpler. Na plus and Cl minus are called spectator ions. They do not take part in the equation. Whenever an acid reacts with an alkali, the overall reaction will be the same as the one above. Useful tips for balancing equations. You must use the correct formulae. You cannot change them to make the equation balanced. You can only change the numbers of atoms by putting a number called the coefficient in front of the formulae. The coefficient in front of the symbol tells you how many moles of the substance are reacting. It often takes more than one step to balance an equation, but too many steps suggest you may have an incorrect formula. When dealing with ionic equations, the total of charges on each side must also be the same. You can use a balance symbol equation to work out how much product is produced from a reaction.